Hey everyone, welcome back to our channel. Today, we have something truly mind-blowing to share. NASA just discovered a neutron star that, according to everything we thought we knew about physics, shouldn't even exist. This discovery is shaking up the scientific community and rewriting what we understand about space, matter, and the very structure of the universe. Stick with me, because by the end of this video, you're going to have a whole new perspective on how mysterious and wild our cosmos really is. First, let's back up a little. A neutron star is what remains after a massive star goes supernova. Imagine a star many times larger than our Sun collapsing under its own gravity. The result? A city-sized object with a mass greater than our Sun. It's incredibly dense, so dense that a single teaspoon of neutron star material would weigh about 6 billion tons on Earth. Neutron stars are fascinating in themselves, but what NASA found recently takes the strangeness to a whole new level. NASA's scientists, using data from the Chandra X-ray Observatory and other telescopes, have detected a neutron star with properties that don't match any known models. It's called XJ 1906 plus 746, and it spins, radiates, and behaves in a way that's baffling researchers. Its mass and rotation rates simply don't add up with what physics tells us is possible. Scientists are left scratching their heads, and it's opening doors to theories we've never seriously considered before. Typically, neutron stars fall within a pretty predictable range of mass and size. If they Q heavy, they're supposed to collapse into black holes. But this particular neutron star? It seems to have skipped that rule. It's too massive to still be a neutron star, but somehow it hasn't collapsed. This defies our understanding of gravitational limits, neutron degeneracy pressure, and even Einstein's theories. It's like finding a bumblebee that shouldn't be able to fly according to physics. Yet there it is, buzzing around. Of course, scientists are hard at work trying to explain this anomaly. Some think it could be an exotic form of matter called quark matter, something theorized but never observed. Others wonder if it's a new kind of hybrid star, part black hole. Still others suggest that our understanding of the forces inside neutron stars is simply incomplete. Regardless, any explanation will likely mean rewriting textbooks and opening exciting new fields of research. The implications of this discovery go way beyond just neutron stars. It touches on the fundamentals of astrophysics, quantum mechanics, and even cosmology. If objects like XJ 1906 plus 746 can exist, there could be countless others out there. It could mean our understanding of matter, gravity, and even space-time itself is just scratching the surface. The universe just got a whole lot more mysterious and a lot more exciting. Neutron stars and black holes are often seen as two stages of a star's death. This discovery suggests that the boundary between them might not be so clear-cut. Maybe there's a whole spectrum of exotic objects in between, just waiting to be found. Could there be neutron stars masquerading as black holes? It's a thrilling thought. Without tools like NASA's Chandra Observatory, the Hubble Space Telescope, and cutting-edge radio telescopes, discoveries like this wouldn't be possible. Chandra's X-ray vision allowed scientists to peer deep into the remnants of the supernova and detect subtle radiation patterns that hinted at the star's bizarre properties. The idea of quark stars, where quarks, the fundamental building blocks of protons and neutrons, exist freely, has been a part of theoretical physics for decades. If XJ 1906 plus 746 is indeed a quark star, it would confirm theories many thought were purely speculative. It would also mean that the universe is even stranger than science fiction imagines. Every so often, a discovery comes along that forces a paradigm shift. Think of how Einstein's theory of relativity changed Newtonian physics. This neutron star might be the catalyst for a similar shift, changing the way scientists model everything from stellar evolution to the end states of the universe itself. Since NASA announced the discovery, media outlets and the scientific community have been abuzz. Social media is full of theories, memes, and excitement. People are fascinated when the universe doesn't play by the rules. It reminds us just how much there is still to learn. This neutron star isn't the only oddball out there. Scientists have found rogue planets, hypervelocity stars, and even entire galaxies behaving strangely. Each discovery chips away at the boundaries of our knowledge and reminds us the universe is far weirder than we ever imagined. This neutron star isn't the only oddball out there. Scientists have found rogue planets, hypervelocity stars, and even entire galaxies behaving strangely. Each discovery chips away at the boundaries of our knowledge and reminds us the universe is far weirder than we ever imagined. Despite centuries of study, we're still in the infancy of truly understanding space. New technology, better telescopes, and global collaboration mean we'll keep uncovering mysteries and probably keep finding things that shouldn't exist. Albert Einstein predicted many phenomena, from black holes to gravitational waves. Each new discovery, including this neutron star, puts his theories to the test. So far, Einstein has held up remarkably well, but even he acknowledged that our understanding would evolve. We're entering a golden age of astronomy. With the James Webb Space Telescope sending back stunning images and new discoveries every month, space science is evolving faster than ever. Discoveries like this neutron star are just the beginning. Neutron stars are notoriously difficult to study. They're tiny on a cosmic scale, emit faint radiation, and are often buried in the chaotic remains of supernova explosions. It's amazing that we can detect and study them at all. If one neutron star can defy the rules, it's likely there are many more waiting to be discovered. Astronomers are now on high alert, scanning the skies for other objects that could further upend our models of the universe. At its core, this discovery is a celebration of human curiosity. We ask questions, we explore, we dream, and when the universe answers with something unexpected, it only makes us more determined to keep looking. So there you have it, folks. NASA's discovery of a neutron star that shouldn't exist is more than just a strange anomaly. It's a cosmic puzzle that challenges our understanding of physics, stars, and even the universe itself. Keep your eyes on the stars. Who knows what we'll discover next? Don't forget to like, subscribe, and hit that bell for more deep space mysteries. Scientists worldwide are proposing new theories in response to this baffling neutron star. Some suggest that the internal pressure inside certain neutron stars could be far higher than we previously estimated, allowing them to maintain stability even when their mass exceeds known limits. Others are delving into quantum gravity theories, postulating that unknown quantum effects might be at play deep inside these stars. Every proposed theory pushes the boundaries of human knowledge and inspires a new generation of astrophysicists. When stories like this hit the mainstream, they often get sensationalized. Some headlines scream about breaking physics or end of Einstein's theories. While this discovery is groundbreaking, science works through careful observation, peer review, and incremental understanding, not dramatic overnight upheavals. Always follow credible sources for the latest developments. When stories like this hit the mainstream, they often get sensationalized. Some headlines scream about breaking physics or end of Einstein's theories. While this discovery is groundbreaking, science works through careful observation, peer review, and incremental understanding, not dramatic overnight upheavals. Always follow credible sources for the latest developments. While it might sound far-fetched, understanding exotic matter inside neutron stars could one day revolutionize space travel. Concepts like antimatter engines, warp drives, or other advanced propulsion technologies hinge on understanding extreme physics, exactly the kind revealed by objects like this neutron star. Neutron stars are often surrounded by fascinating phenomena, powerful magnetic fields, particle jets, and gravitational distortions. This particular star could host exotic phenomena we've never seen before. Further study might reveal entirely new types of radiation, gravitational interactions, or cosmic structures. Discoveries like this neutron star ignite the imagination of young minds. Somewhere out there, a kid hearing about this impossible star will dream of becoming an astrophysicist, an engineer, or an explorer. The universe's mysteries are the greatest fuel for ambition and curiosity. Discoveries like this neutron star ignite the imagination of young minds. Somewhere out there, a kid hearing about this impossible star will dream of becoming an astrophysicist, an engineer, or an explorer. The universe's mysteries are the greatest fuel for ambition and curiosity. Interestingly, the quest to understand the stars has always driven technological innovation here on Earth. From better cameras and imaging software to new materials and computer algorithms, studying neutron stars and the cosmos at large continually pushes tech forward, benefiting us all. If this discovery teaches us anything, it's to expect the unexpected. Science isn't about confirming what we already know, it's about uncovering what we don't. And when the universe throws us a curveball, like XJ 1906 plus 746, it's a thrilling reminder that reality is often stranger and more beautiful than fiction. This isn't the first time the universe has surprised us. Pulsars were first mistaken for alien signals. Quasars were initially thought to be stars. Dark matter was proposed because galaxies moved in ways they shouldn't. Space is a history of the unexpected, and this neutron star is its newest chapter. When anomalies appear, there are sometimes the first hints of a revolution. Just as strange orbital motions led to the discovery of Neptune, or anomalies in Mercury's orbit led to general relativity, this neutron star could be the starting point for physics beyond what we know. When anomalies appear, they're sometimes the first hints of a revolution. Just as strange orbital motions led to the discovery of Neptune, or anomalies in Mercury's orbit led to general relativity, this neutron star could be the starting point for physics beyond what we know. Even though the discovery is exciting, it's important that findings go through rigorous peer review. Other scientists will examine the data, try to replicate the observations, and propose alternative explanations. Science progresses cautiously, ensuring that new ideas are as bulletproof as possible. Major cosmic discoveries often influence culture, from sci-fi movies to art, literature, and music. Who knows? Maybe this impossible neutron star will inspire the next blockbuster film, a novel, or even new philosophical debates about existence itself. Major cosmic discoveries often influence culture, from sci-fi movies to art, literature, and music. Who knows? Maybe this impossible neutron star will inspire the next blockbuster film, a novel, or even new philosophical debates about existence itself. The fact that something so seemingly impossible can exist reminds us that there's so much we don't know. It raises big questions. What else is out there? What hidden rules govern the universe? Can we ever truly understand it all? Every time we look deeper into space, we find more surprises. The cosmos isn't just vast, it's incredibly creative, weaving together phenomena that defy logic and challenge imagination. And that's what makes astronomy one of the most exciting fields of science. Every time we look deeper into space, we find more surprises. The cosmos isn't just vast, it's incredibly creative, weaving together phenomena that defy logic and challenge imagination. And that's what makes astronomy one of the most exciting fields of science. Now that this neutron star has challenged the norm, scientists are keeping their eyes peeled for more unusual objects. With new instruments coming online, like the Square Kilometer Array, SKA, and next-generation gravitational wave detectors, we may be on the verge of a golden age of strange star discoveries. Neutron stars already push the boundaries of quantum mechanics. But if this star's internal structure includes exotic forms of matter, like free quark soup, then quantum mechanics might need new rules or extensions to explain such extreme environments. Quantum physics could be due for another evolution. This discovery isn't just about matter, it's about gravity too. If neutron stars can exist outside the known limits of mass, our models of gravitational collapse may need serious adjustments. Scientists may even have to revisit alternatives to Einstein's general relativity, like theories of modified gravity. Think about neutron stars as natural laboratories, places where temperatures, pressures, and forces reach extremes impossible to recreate on Earth. By studying them, we glimpse conditions that could answer some of the most profound scientific questions ever posed. Translating complex discoveries into understandable and exciting stories is crucial. Channels like this one, along with science communicators, journalists, and educators, make sure that groundbreaking news like the neutron star that shouldn't exist inspires millions instead of staying locked in academic papers. It all comes back to one simple, powerful thing: curiosity. Curiosity is what drives scientists to explore the night sky, question established facts, and stay up late running simulations. It's what brings discoveries like this neutron star into the light of human knowledge. Astronomers believe that for every object we detect, there are dozens more we miss. Strange neutron stars, rogue black holes, invisible planets. The universe is teeming with hidden phenomena, just waiting to be found. New telescopes like the Vera Rubin Observatory and space-based X-ray missions promise to give us even sharper eyes on the universe. They might help us discover not just one, but dozens of impossible neutron stars, revealing entire new classes of cosmic objects. The universe constantly humbles us. Just when we think we've figured it out, a neutron star like XJ 1906 plus 746 pops up to remind us knowledge is never complete. There's always a deeper layer, a hidden truth waiting for discovery. And that's what makes exploration so beautiful. Imagine if this discovery is just the tip of the iceberg. There could be stars made entirely of dark matter, magnetic monstrosities, or objects governed by unknown forces. This neutron star hints at a universe that's far more complex than we dared to imagine. Some speculative physicists even propose that extreme cosmic objects could hint at multiverse interactions, tiny signs that our universe isn't alone. While highly theoretical, it's fascinating to ponder how much bigger reality could be. Artists, poets, and novelists have long been inspired by cosmic events. Perhaps this neutron star will find its way into the next great space opera, a moving poem, or a mind-bending sci-fi novel. Maintaining public interest in space exploration is vital. Discoveries like this neutron star remind us that space isn't just an empty void. It's a living, breathing mystery, always surprising us with its wonders. Every atom in our bodies was forged in the heart of a star. Discovering new stellar phenomena reconnects us to the cosmos, reminding us that we are literally children of the stars, still learning about our ancient origins. We owe so much to the engineers who build telescopes, the programmers who write complex simulations, and the scientists who dedicate decades to studying these phenomena. Without them, we would still be staring at the night sky, wondering blindly. Understanding the universe isn't about finding all the answers. It's about continuing to ask better, deeper questions. Every new discovery, every neutron star that defies explanation, is another chapter in humanity's never-ending quest for knowledge. If you're fascinated by discoveries like this one, stay tuned. Follow trusted scientific journals, space agencies like NASA and ESA, and channels like ours. The universe has many more secrets to reveal, and you won't want to miss a single one. Never lose your sense of wonder. Whether you're a scientist, a student, or simply someone who loves gazing at the stars, wonder is what fuels exploration. And in a universe as strange and beautiful as ours, there's an endless supply of it. Never lose your sense of wonder. Whether you're a scientist, a student, or simply someone who loves gazing at the stars, wonder is what fuels exploration. And in a universe as strange and beautiful as ours, there's an endless supply of it. Most neutron stars we've studied fit neatly within expected mass and density ranges. But XJ 1906 plus 746 isn't just slightly different, it's dramatically different. This outlier challenges assumptions that have stood for decades, showing just how little we still know. Excitingly, upcoming missions like NASA's Lynx X-ray Observatory and ESA's Athena mission are set to gather even better data on neutron stars. These advanced observatories will allow us to peer deeper into the hearts of these strange objects than ever before. Artificial intelligence is becoming a major player in space research. Machine learning algorithms can sift through mountains of data to find anomalies exactly like this neutron star much faster than humans alone could. I might uncover the next big cosmic surprise. This discovery doesn't just shake up textbooks, it may completely realign how we teach astrophysics. Concepts about stellar evolution, matter under pressure, and gravitational collapse may all need updating based on what we learned from XJ 1906 plus 746. Some bold scientists are proposing a stunning possibility. Maybe XJ 1906 plus 746 isn't a neutron star at all, but something entirely new. A previously unknown type of ultra-dense object, the first of its kind ever observed. This neutron star is already sparking major conferences and symposiums. Researchers are gathering to brainstorm ideas, share models, and debate possibilities. The buzz around this discovery is energizing the entire astrophysics community. If neutron stars can exist at higher masses, it also affects our models for black holes. Where we once thought the line between neutron stars and black holes was clear, we now realize it might be blurred with new and unexpected types of objects in between. There's a certain beauty in not knowing.